Stay cable arrangements. Three main configurations are generally used for the system of stay cables in extradosed bridge. These include the fan system, the harp system and the semi-fan or modified fan system. In the fan system, all stay cables converge or radiate from the top of the tower. According to the experience with this configuration in conventional cable stayed bridge, it leads to the most efficient structural system since it is entirely composed of triangles. However, anchoring all the stay cables at one point at tower top will be very difficult and therefore the fan system is often modified. The modified system is called semi-fan or modified fan system. In the harp system, the stay cables are connected to the tower at different heights and are parallel to each other. From an aesthetic point of view, this system may be preferred. In extradosed bridge, the stay cables are generally disposed in one vertical line above the bridge center line or in two vertical planes at the edges of the girder. When stay cables are arranged in the central vertical plane of the girder, they only provide horizontal and vertical support to the girder. They provide no torsional support to the girder. Fortunately, the girder of extradosed bridges often consists of a hollow box girder, and hollow box girders are well known for their higher torsional stiffness. The two vertical planes arrangement provides horizontal, vertical and torsional support to the girder, and there is not any other necessary additional torsional stiffness requirement from the girder. Tower types. It may depend on whether the stay cables are arranged in one central vertical plane or in two vertical planes. For a box girder bridge, the ratio of side span length to the main span length is determined between 0.65 and 0.7. A ratio between 0.65 and 0.7 is acceptable for the preliminary design of an extradosed bridge. This range may be also used for extradosed bridge, since the ideal here is to design the girder of extradosed bridge like that of box girder bridge. The ratio LS/L between the main span and the side span should be in a certain range so that its influence on the anchor pier and the backstay cable can be reduced. Since it's expected to design an extradosed bridge that will cost approximately what a box girder bridge will cost, the main span length of an extradosed bridge should be kept between 100 and 200 meters. But instead, the span range is kept close to that of the box girder bridge so that the remaining span cost can be used on the design of the extradosed pre-stressing. Cable spacing and girder segment length. In cable stayed bridge. In cable stayed bridge, the cables act as an elastic support for the deck. Therefore, the moment distribution along the deck of a cable stayed bridge is influenced by the number of cable used to support the deck. The use of smaller number of cable leads to large spacing between cable attachment points. This requires greater diameter cables and bigger girder depth with complicated cable attachment. But the use of big number of cables leads to small spacing of cables. The multiple stay system has the advantage of smaller diameter cable, smaller stayed girder depth, improvement in girder longitudinal bending moment, simpler cable attachment and easy replacement of cables. Cables are spaced depending on the available form travelers, or form travelers are designed according to the required cable spacing and segment length. According to the current practice, cable spacing is chosen between 5 and 15 meters on the deck and between 2 and 3 meters on the tower. In extradosed bridges, the cables do not play the same role like those in cable stayed bridge. The extradosed system is to improve the flexural behavior of the girder instead of providing the girder with elastic vertical supports. Nevertheless, the above described multiple stay system and erection method for cable stayed bridge can still be applied in extradosed bridge, but additional considerations are required. In case of precast concrete segment construction, the weight and the length of concrete girder segments should meet the transportation requirements. It's found that cable spaces chosen between 4 and 6 meters on the deck and between 0.8 and 1.2 meters on the pylon are reasonable for an extradosed bridge. The space between the two cables located in the middle of the main span around middle key segment may be between 1 and 2 meters or greater, but should not exceed 0.1 times the main span length. The attachment point of the first stay, that is the shortest cable, according to Matthew, should be fixed at 0.1 from the main span length. This part of the extradosed girder contains a big amount of pre-stressed steel, and therefore the first cable should be a little far away from the tower. This value 0.1 L can be reduced but should not be less than 0.075 L. Girder depth. The determination of girder stiffness does not only take into account the stay layout but also the depth of the girder. In case the superstructure consists of box girder, a very deep girder will result in a heavier superstructure and will be subjected to higher transversal load effect. Therefore, the girder depth should take a minimum value that will satisfy the stability and economy requirements. The girder of an extradosed bridge can be determined from that of the corresponding box girder bridge by moving out an amount of internal pre-stressed steel. The removed quantity of internal pre-stressed steel will be a part of the total quantity required for the design of the extradosed pre-stressing. This of course will lead to reduction in girder depth. In general, a reduction in girder depth produces a decrease in concrete volume. And concrete volume decreases as the span-to-depth ratio increases. A box girder with higher span-to-depth ratio will require a big amount of pre-stressed steel. The pre-stress demand caused by the increase in the span-to-depth ratio will be easily satisfied in extradosed bridge. At span middle, 50 L/HM 64 variable depth. Constant, 32 L/HT equals L/HM 38. Extradosed girder was then suggested as follow. At piers. At span middle. Constant. In terms of quantity, it's found that 30 decrease in girder depth will produce 48 decrease in pre-stressed steel. In terms of structural behavior, a girder with 48 decrease in pre-stress consumption may suffer from instability even though the girder dead load has decrease. Fortunately, the extradosed pre-stressing will compensate this lack of internal pre-stress. It's expected that girder depth determined in accordance with the above criteria provides satisfactory for economy, serviceability and aesthetic requirements. Tower height. In extradosed bridges, the tower plays the role of deviator. It helps in improving the structural behavior of the girder by providing the girder with pre-stressing moment through the cables. This is due to its smaller height and the larger eccentricity of the extradosed cables. The cable inclination has been identified as an important parameter for the determination of the criteria that govern the choice of the tower height during the preliminary design process of extradosed bridge. In extradosed bridge, cable must be inclined enough to produce higher horizontal compressing force in the girder. However, the tower height should not be too small to avoid smaller lever arm and aesthetically poor structure. Therefore, the height of the tower should be kept to a reasonable minimum that will provide satisfactory for service, aesthetic and economy. It's found that a maximum value of 0.33 radians is reasonable for cable inclination controls somehow the tower height, cable length, the lever arm and the horizontal component of the cable tension between 0 and 90 degree. A decrease in cable inclination produces an increase in the horizontal component of the cable tension, but produces a decrease in tower height, cable length and lever arm. Previously, it was found that, in extradosed bridge, the inclination of the first cable should not exceed 0.33 radians or should keep H1 between 0.025 L and 0.034 L. It can be concluded that, in extradosed bridges the inclination of the cable should vary between 0.17 radians and 0.33 radians. Connection. The structural behavior of an extradosed bridge depends on how the structured components are connected between them. And also the individual behavior of each component depends on its connection with other components. Connection between cable and girder. The connection between cables and girder is achieved by the use of anchorage system. Cable-stayed bridge. In a cable-stayed bridge with few cables supporting the girder, The connections of the cables with the girder are more complicated since the tension forces in the cables are big. Generally, for concrete girder, diaphragms are provided at the cable anchorage points. The cable forces are transferred to the girder through the anchorages. In extradosed bridge, the connection between the cables and girder is similar to that of cable-stayed bridge. But the extradosed cables are more considered as pre-stressing tendons. The support of the extradosed girder does not rely too much on the cables. The girder is designed to be able to carry a big part of the total dead load, about 60. The resulting forces in the cables are small. The stress variation limit on the cable anchor points is higher. Connection between cable and tower. There are mainly two types of support used to transfer loads from the girder to the tower. This includes an anchorage system and a saddle system. The support may be fixed or movable. Fixed support. The cable attachment points on the girder are only allowed to move vertically. This may give rise to bending moment at the top of the tower. Saddle system, anchorage system. Movable support. The movable support does not allow bending of the tower top. The application of the movable support is very rare as it reduces the structural efficiency of the system.